Hello, welcome to Ms. O Math Help. In this video, we are going to look at multi-digit division, in particular, division where the divisor is 2 digits and the dividend is 3 or more digits. We are going to look at 2 methods for solving these types of problems. Before we get started with the division, let's review vocabulary that goes along with division problems. So let's look at a division problem here that is written in standard form. 864 divided by 32 equals 27. So the 864 is what we call the dividend. And I always remembered that as a student, being that that's the number that we divide into. The 32 is called the divisor, and the 27, which is the answer to a division problem, is called the quotient. And then here is another example of those 3 numbers where we use what we call the house method, where we put the dividend under the roof or under the house or in the house. So we have the yellow 864 is the dividend, the orange 32 is the divisor, and then the quotient goes on top. All right, let's look at long division first. So long division is our standard or traditional method for dividing numbers, especially numbers where we have more than 1 or 2 digits involved. So let's look at 391 divided by 17 first. I have a mnemonic device to help us remember the steps. The steps are divide, multiply, subtract, check, and bring down. And the mnemonic device is a question: does McDonald's sell cheeseburgers? And this will help us because the first letter of each of those words is the same as the first letter in each of the steps. Okay, so let's begin. What I want to do first is I want to look at the first digit in my dividend and ask myself, can 3 be divided into 17 groups, or can I divide 3 by 17? I cannot. 3 is too small. So then I add a digit and I look at 39. Can 39 be divided by 17? It can. So I want to decide how many 17s can I fit into 39 without going over. Excuse me, I can fit 2 17s into 39. So that was my first step, was divide. My next step is multiply. So I'm going to multiply the 2 times the 17, and the product of that goes here. The next step is subtract. So I'm going to subtract 34 from 39, and that is going to be 5. My next step before I continue is to check. And what I want to do is I want to take that 5 and ask myself, is that less than the original divisor? It is, so that checks. So now I can continue. I'm going to bring down my 1. So there's my 1, and then I start over. After that purple step, I start back over with the red step, divide. So let's divide 51 divided by 17, or how many 17s can fit into 51. If I'm not sure, I can just, try a couple, like 17 times 2. We know that's 34 because we did that. So maybe it'll go 3 times. 17 times 3. Well, that's 21, and 3 times 1 is 3, plus 2 is 51. It actually goes evenly 3 times. So I'm going to put a 3 there, and then I'm going to multiply. 3 times 17 is 51. I'm going to subtract, and I get 0. So at the end, if I have a 0, then I'm done. Here's another practice problem. Let's see how we do with this one. Let's first divide. Well, I know that 23 times 2 is 46. So I am going to take the first 2 digits and divide those by 23. 23, and I'm going to put my 2 up there. 2 times 23 is 46. And then I'm going to subtract, and that will give me 3. And then I just check to make sure. Is 3 less than 23? It is, so I can move on, and I can bring down my 4. Okay, and then I ask myself, how many 23s can I fit into 34 without going over? And I can only fit 1. So I'm going to put my 1 here, and then I'm going to multiply. 1 times 23 is 23. When I subtract here, I get 11. Okay, I don't have any more numbers to bring down, and so there's no more dividing to do. I need to just check one more time and make sure that the number that I got, 11, is less than 23. It is. Okay, so because it's less than 23 and it's not 0, I have a remainder. So depending on your grade level and what you're required to do, your answer might be 21 remainder 11. If you are required to change this to a fraction, then what you would do is you would answer this 21 and 11 over 23. So the original divisor is the denominator, and what's left over is the numerator. Okay, so that's long division. Next, we are going to look at something we call partial quotient division. Sort of the same way we can describe multiplication as repeated addition. So if we were multiplying 4 times 3, for example, we could add 4 3 times. We can describe division as repeated subtraction. If I gave you the problem 12 divided by 3, what we could do is we could take the 12 and subtract 3's and keep subtracting 3's until we get to 0. And then we ask ourselves, well, how many times did we subtract? Well, we subtracted 1, 2, 3, 4 times till we got to 0. So that means 12 divided by 3 equals 4. And you can do lower level division like this. When you get to a problem such as 3,645 divided by 18, what you don't want to do is you don't want to subtract 18 as many times as it would take to count up what the quotient would be here. So we use a method called partial quotients. If we did that, if we subtracted 18 as many times as it took, it would be in the hundreds. So we really don't want to take the time to do that. So partial quotient division is another method that we can use in a problem such as this one. The way it works is instead of finding 36 divided by 18, what we do is we try to find friendly numbers that we can multiply times 18 to get a product here that we can subtract. We're trying to find a partial quotient to multiply times the 18 instead of just 2. Okay, so what I know is that I can take 18 and pretty easily multiply it times 200. 18 times 200 is 3,600. As long as this number is less than your original dividend, this number here, the 3,600, then that will work and you can use that number. And it doesn't matter, honestly, it doesn't matter what number it is. You just can use it as long as it is less than your original dividend. So this, though, the 200 is what we call a partial quotient. So that's just going to be part of the answer or part of the quotient. So I'm going to write my 200 over here to the side. I'll come back to it, but I'm going to write that there for now. And then my 3,600, I'm going to put under the original dividend. So that's the product of 18 and 200. And then I'm going to subtract. And when I subtract, I get 45. So I'm almost done. I've got a much smaller number to deal with here. So then I'll ask myself, what is something that I can multiply times 18 to get close to 45? Well, 18 times 2 is going to get me close to 45. 18 times 2 is 36. And that's about as close as I can get. It is as close as I can get without going over, because 18 times 3 would put me over 45. So this number will work. And again, I'm going to put my 2 here. And then I'm going to put the 36 here and subtract. And that is 9. So I have my partial quotients, and I'm going to highlight those. So 202 are my partial quotients, and you remember with partial products, you just add them together. So we're going to add together the 200 and the 2 for 202, and then my remainder is 9. So 202 remainder 9. If you are in a higher grade level, 6th, 7th grade possibly, and you're required to write this as a fraction, it would be 202 and 9/18, and then maybe you are required to simplify your fraction. That would be 202 and 1/2. All right, I'm going to work one more problem with you. So we have 7,755 divided by 33. So let's see, what partial quotient can we use first? Let's do, well, I know 33 times 2 is 66. So if I did 33 times 200, that would be 6,600, and that is less than 7,755. So 6,600 with a 200 right here would be a good number to start with. So let's subtract. Let me move that over a little bit. That's way too close. So my 200 we'll put over here, and 200 times 33 is 6,600. Let's subtract here. That's going to be a 5, a 5. That's going to be 1,155. All right, so I know 200's too high. I also know 100's too high because 33 times 100 is 3,300. So I can't use that down here. I need something smaller. Let's try 33 times, let me grab a different color here. Let's try 33 times 20. Okay, so 33 times 2 is 66, and then add a 0. That looks like a good one. So let's put a 20 here. 660. Let's subtract. 5 minus 0. Let's go 0 there. That's a 15. 15 minus 6, 9. And then 10 minus 6, 4. So I'm left with 495. All right, so 33 times 20 is obviously going to be too big for a partial quotient because 660 is greater than 495. So let's maybe try, we can do 33 times 10. 33 times 10, so let's put my 10 here. Whoops, grab my marker. Let's put my 10 here, and that would be 330. I'm running out of room, but I can move it over here if I need to. Okay, that's 5, and that's 6, and that's 1. So now I have 165. Well, 33 times 10 is too big because that's bigger than 165. Let's try 33 times 5. I'm going to put it over here, just out of the way. That's going to be 15. And 5 times 3, yep, that works. So 5, let me grab one more different color here. So I'm going to put a 5 here, and 33 times 5 is 165. So 165 minus 165 is 0. So I have all of my partial quotients ready to go, and they are 200 plus 20 plus 10 plus 5. So I bet we can do this without writing it all down. 200, 220, 230, 235. So it looks like my answer is an even 235 with no remainder. So in this video, we first looked at long division, which has specific steps that we do in order, and we do those steps and repeat them until we get to 0 or until we get to a number that is less than our original divisor. So this is the type of problem here that would be a long division problem. And then we did a partial quotient division problem where we looked for friendly numbers that we could multiply times our divisor and then subtract that product from the original dividend. We got down to 0, or again, a remainder that is between 0 and the original divisor. So I hope you enjoyed this video. If you have any questions, please be sure to leave a comment and like the video and subscribe to my channel. I appreciate your watching, and I'll see you next time.